Hello everyone. So in this section from our Math 60 textbook, section 6.1, we are basically trying to deal with rational functions, and the word rational, like we've been talking about, have been coming from when you have things in the form of ratio, like such as P over Q. All of these are rational, right, in the forms of ratio. So last time we really mastered our factoring skills and we took an exam on factoring, and then our idea over here is also gonna help us to do more factoring techniques. So let's see. Find the domain of each rational expression. So when we're talking about rational expressions, in other words, we're basically saying, let's forget about the question. We're saying what value of x that will give me a 0 on the bottom. Like whenever you have a number divided by 0, that is, we don't know what the answer is, that is undefined, versus whenever you have a 0 divided by another number, that is 0. So that's okay, but you can't have a 0 on the bottom. That's a problem. So that makes a rational function undefined. Whenever you have a 0 on the bottom, that makes the rational function undefined. And that is part of the domain. So on letter A, when we're looking at this, what value of x, or what value can make the denominator go to 0? Now if you think about it, there is no values here. Why? Because you don't have a x in here. Like 4 is just a number. So you could have rewrote this question as something like this. There is no bottom in over here. There is no bottom. 1/4 or 4 is multiplying or dividing. So there is none. So the answer is, for over here, the domain would be x such that x is any real number. Or one could have said it's negative infinity to positive infinity in interval notation. But when we look at letter B, it's a rational function, but now you also happen to have a x on the bottom. So the question arises, what value of x will result to a 0 on the bottom? So if you think about it, can I have x as 1? If I take x as 1, what happens? I get a 5. If I take x as -1, I get a -5. What value of x can I take that's going to get me to a 0? Well, in this matter, it is only x it would get you to 0, right? Because 5 times 0 would be just a 0 on the bottom. You can always check if you plug it in over here on the numerator as well, you're going to get 0 over 0, and then that's a problem, we can't do it. But in calculus 2, we can actually prove this using something what we call L'Hopital's. So you'll see it again down the road. So you're going to set that denominator. Notice what we are doing. If it's harder for you to think of that number, and it's going to eventually get even more harder, you're saying what value of x will get me to 0? Well, we know how to solve this. If I divide both sides by 5, so I have x would get you to 0. So the value of x that will get me to 0 is 0. So whenever you write domain, it's kind of tricky here. You're saying x is all values besides x cannot be equal to 0. You're saying all values x can have besides it's not equal to 0. But in the beginning, notice what we did is we actually solved it for 0 because we were actually wondering what value of x should get me to 0. So bottom line is, take the denominator, set it equal to 0. So I will write out the steps. Set denominator equal to 0, and then when you write your domain, you are saying x is not equal to that number that you find, and you're pretty much done. So letter C, you're basically doing the same thing. What value of x can you really not plug in? So if you really think about x, what value, if it says 0, hell, let's say if x is 0, I would have -7 plus 0, which is still -7. I do not want a 0. So remember, take the denominator. So our denominator is -7 plus x, and we are setting it equal to 0, and we're saying what value of x I cannot have. Let's just solve for x. Let's not think about it. So plus 7 on both sides. So I would have x equals 7. Now notice, you're gonna get a wrong answer if you say x is 7, because you're saying that I can actually input 7 in there, but technically you cannot put a 7 in there. X can be any values in the world you give me, but if I put 7 in here, that's gonna get result to a 0 on the denominator. So that's the answer for letter C. So all of those was easy. I'll let you try D on your own. Let's talk about something a little more difficult one. So over here you can say what value of x that I cannot have it on the denominator. Well, out of so many values, now it gets more complicated because you got an x here and also you got an x here. Yes, you can always do a trial and error. Like, hey, what values? You can start running numbers, x is 5, x is -5, 0, -1, all of those. But we don't want to do that. We want to be more efficient, right? So what we're trying to do is user critical thinking. Like last class, we know how to take care of this guy, right? If you look at all of those problems, we set the denominator, which happens to be 2x squared plus x minus 3, and we're saying what value of x I cannot have. And from last class, you guys just took an exam on factoring. We know how to crack this. This is called a trinomial. And it's not an expression, rather it's an equation now, because we have an equal. So what we did from last class, remember that AC method, 2 times -3 is -6, and the coefficient of x in the middle is 1. So how can we break -6? Okay, think about those numbers. So you might think 6 and 1. 6 and 1 is going to get you 5. Right, or 7, but I need a 1. Maybe someone's thinking 3 and 2, but I need to make it as a positive 1, so maybe this is -2. So remember, you cannot just put x plus 3 and x minus 2 because you have a 2 out in front. So how we handled those is we factored out by grouping. So the first term and the last term remained exactly the same, and then we basically split those middle two terms into this, and then we took 2 at a time. From the first two terms, you can probably factor out 2x or an x, so you'll have 2x plus 3. From the last two terms, looks like there's nothing to factor out, so you take out that sign, very important, and a 1. 2x minus 3, let's check my work. -1 times 2x is -2x. -1 times -3 oops, you see, I did something wrong. And remember, I always said in class that this right here and this right here must be the same. Well, they're not the same, means did I do something wrong? When I checked, -1 times -3 is a positive 3, which I don't have, so it needs to be a positive here. So bingo, now I have it. Remember, always this inside guys have to be the same in order for your factoring to write, if you look at our lecture notes. So you have x minus 1 and 2x plus 3 are those numbers, are those factors. Then you use the zero product property. Then we said x minus 1 equals 0 and 2x plus 3 equals 0, and if you solve for x, you'd get x as 1 and x as -3/2. So we found those numbers. Now when you say your domain would be x such that x is not equal to -3/2 and 1. It doesn't matter how you write them, it's just nicer to write from lowest, from the negative to the positive. So that's your domain. So things are gonna get harder when you have a little bigger mess. You can't do a trial and error. You're taking really the denominator and you're saying what values of x will result to a 0, and then you basically say those x values cannot be part of my domain. That's it. Number 2, notice on the previous question it asked you to find domain. It did not ask you to simplify. When it asked for domain, take the denominator, set it equal to 0. Here my new question is simplify, so I need to simplify as I go. So we liked factoring, at least from the problems that we did in class. So now you need to break the numerator and the denominator at the same time. So if I break the denominator or I mean the numerator, what can we factor out? So we talked about GCF and all of those stuff on the previous chapter, chapter 5. So we can factor out a 2 and also maybe an x. And from the bottom, I cannot factor out anything, so I'll just leave my 2x alone. So from the first term, if I already took out a 2x, I need a x and I need a 3. So that's it. I cannot do anything else. And now we like our canceling techniques. Once you factor, you're allowed to cancel out the 2's here, the x here. So your final answer is x minus 3. As a good habit, we're going to put them inside a parentheses. And that's my answer. So this is what I do not want you to do. You cannot cancel this x with this x, or this x with this x. The only reason you cannot take them out, because on the numerator you have 2 terms. You can only take them out if there is some numbers or variables in the form of a factor. We'll look at some more examples. Let's see letter B. So if you look at the numerator, you might be thinking, well, we can't factor out anything, but remember there are a couple of things we learned in class. It goes with the formula. There is a name to it. We called it difference of squares. So you could have said this is x squared minus 9 squared, and we call those a's and b's. And it goes like a plus b and a minus b. So this would be x plus 9 and x minus 9 all over. I cannot factor the denominator at all, so I'll use my good habit, as I can put 9 plus x. Also, one can put as x plus 9. It really doesn't make a difference, whichever looks easier to you. Once you factor, you basically simplify. 9 plus x and x plus 9 is the same thing, so your final answer is x minus 9, and you're done. Letter C, same kind of idea. You're going to factor out the top, the numerator. So for the top, I'll go ahead and do this. Bottom, I don't think I can factor anything, so I'll put them inside the parentheses. So you need to break 25 to get to 2 numbers. That gets you negative 10. So think about those numbers. Okay, so I hope you have those numbers. Remember, there was also a trick in class we did. We basically said, if, like, without factoring right here, if the first term is a perfect squared, which is perfect squared of x, if the last term is a perfect squared, which is also maybe a 5, take the product of those two, which is 5x, and if you double it, that's that term, then you can actually. However, what sign do you get is the sign in the middle. If you look at in class what we did, minus 2ab plus b squared can be written in the form a minus b getting squared. If you have a, what happened here? If you have a minus, this is a minus. If you have a plus, then this is a plus. The last always stays a positive. So we can actually imply that over here. So this would be this all over x minus 5. And if you also thought about those numbers, doesn't matter, it would be negative 5 and negative 5. And then you would have done x minus 5 and x minus 5, which is the same thing as x minus 5, the whole quantity getting squared. So now we have it as a form of a factor. So we can you got 2 of them on the top, and you got 1 of them on the top, on the bottom. So this is like you're saying, if you have m and m, because you have 2 of them, and on the bottom you only have 1 of them, you only cancel 1. So you're basically doing 2 minus 1. So these guys are gone, this is gone, but you would have 1 more of them. So your final answer is x minus 5 raised to the 1, which we don't write it, or you can write it, there's nothing wrong to it, and that would be your final answer. If you look at letter D, it almost looks the same. And I know we are very tempted to cancel, but no, you cannot cancel. Because on the top, you can't factor anything, so this is like x minus 8 itself. And this is 8 minus x itself. And you cannot cancel, cross cancel, or any of those. So how we work is whenever they looks almost the same but not the same, you can make them look the same. I'm going to leave my top the same, but from the denominator, I can factor out a negative 1. And remember, when you take out a negative 1, sign gets changed. So negative x becomes positive x, positive 8 becomes negative 8. And now they're exactly the same. So your answer is negative 1. So the bottom line is when it looks the same but not the same, pull out a -1 from whichever top or bottom, and then simplify. Try the E and F